We'll talk about Ohm's law and how we use some of this stuff. Technically, the ohm was defined as an electrical resistance between 2 points of a conductor when a constant potential difference of 1 volt was applied to those points and produces in the conductor a current of 1 ampere. The conductor not being the seat of any electromotive force, which means there's no other battery or voltage source that's affecting it. Basically, that says this formula, resistance is equal to the voltage divided by the current. It's the ratio of the potential versus the current. And Ohm actually derived that experimentally by taking different types of material and actually measuring the amount of current at different voltages, and found out that they basically plotted a straight line for this particular material. And that's how he developed that formula. He wasn't a theoretical or experimental physicist. He just was an experimenter. This is kind of an example of how he did it, and if you plot voltage versus current, you're going to get this straight line and the slope of that line is the resistance. So it's the standard first order linear formula of Y equals mx plus b. And you can substitute the EI and R terms, and you come out with the potential is equal to the resistance times the current plus the offset from 0. In this case, there's no offset. It's linear and goes through 0. Okay, here's a little pie chart, which a lot of people find very useful in remembering Ohm's law. The principle is that you divide that circle in half, and then you divide one of the halves in half, and you put E on the top and I and R on the bottom. So if you want to solve for, let's say, the voltage, you put your finger over the E, and it says that the voltage then would be equal to the current times the resistance. If I wanted to solve for the current, put my finger here and it says it's equal to E divided by R. If I want to find R, it's going to be E divided by I. So instead of writing all three of those formulas down or remembering from algebra how you just manipulate them, you can just draw your little chart on the back of your answer sheet if you have trouble remembering it. And that's perfectly fine. It helps a lot of people.
Yeah, definitely memorize that little circle.
Particularly people that didn't have algebra. Or people that hated algebra. So what formula is used? Did you write your circle down? Did you write your circle down?
No, I didn't draw the circle. I just.
Okay. What formula is used to calculate voltage in a circuit? And what voltage?
The voltage divided by the current, so that would be V. V equals voltage divided by R. No, we just went over that.
E's at the top.
So you got the diagram on the paper.
Let's see here.
So if you put your finger over E, what's
I've
left?
got, okay.
So you put your finger over E on your diagram. What's left? And they're adjacent to each other, right, side by side.
So would that be a multiplication?
Voltage divided by the current.
That's the multiplication.
The side by side is multiplication. Because we cover the I or the R, then E is over one of the other two. That's it.
Got it?
That's why
Right,
you look at that chart, then you look at this. Much easier to remember that little circle, because here you gotta look at every one of them, you kind of have to really think through it, if you remember that diagram.
well, we got times, got divided by, plus, and minus, so it'd be E, it'd be B, wouldn't it? Divided by
E, I times R.
I times, oh, okay, yeah, I see it's A.
Yeah, because you cover the E on your little pie chart that you, like, look at the answer. You know, it's not plus and minus, nothing's plus and minus, like if you just were initially looking at that, it's to say, well, it's gotta be A or B. Because there's no plus or minus in the formula, right? It's I times R or E over I or E over R, so you know plus and minus are out right off the bat.
And you can't add current and resistance or subtract them. So that's why Charlie and Delta are nonsense answers.
Process of elimination, you know, it's not very stupid. Yeah, just remember in your diagram that the I and an R are being adjacent.
Try it again.
It's multiplication.
What is used to calculate resistance?
Calculate resistance.
Remember, you got E over I and R. You want R. What's that leave?
Put your finger over R, what's left on the diagram.
So this times. E times I would be,
No. E, line, I. Divided,
E divided by I will equal resistance.
yes.
So we beat. Resistance, right?
How about that?
I'm slow, but I get there eventually.
That's all right. All right, one more try. How do you calculate current?
Well, that'd be A, E times R. Let me see, E, yeah, E times R. Over.
Well, if you think about, I just think about conceptually, you know, you have. Like water, I was always taught the water thing, so. You have a bunch of potential energy, your voltage. The rate of flow is gonna be your current, so you're basically, you're dividing your, potential by your resistance.
Right.
So if you have more resistance, then less water is gonna flow. You know, so.
Right.
So you think about it, John, it's a little more deeper than I think about it, because I just look at the chart, put my finger over the eye. But
I
that works.
E divided by I.
You can like that.
Excuse me, R.
Yeah, draw that thing on the back of your answer sheet, for sure. Because like I said, if you just cover the eye,
Okay.
we want to know current, cover it. What's left? E over R. You know?
Yeah.
So memorize that circle and just cover up the one they're asking about.
In fact, if it helps, on this line, even instead of that line, draw a little X for it times, if that would help.
That is implied. You have to know that.
Okay, here's some practical examples. What's the resistance of a circuit in which a current of 4 amps flows when it's connected to a 120 volt source? So I know the voltage, I know the current. I want to know the resistance. So I want R.
So you want E divided by R. Right?
Well, I want R, I don't know R.
Yeah.
I know E and I.
Okay.
So what do I do with them?
So E divided by I,
All right,
Mhm.
okay? You got 120 volts
all right,
and you got 4 amps. So
Right.
that's gonna equal 30 ohms.
all right.
All right, where's the resource? So,
So let's do the 12 volts and 2 amps.
hey, E divided
Same
by
formula.
I,
Just plugged in different numbers. And here we got 3 amps and a 12-volt source. So it must be how many? 4 ohms, right?
Mhm.
So what's the current if we have 120 volts and a resistance of 60 ohms?
So I would equal ER. So you got 120 divided by 60 volts, ohms,
All right. You get 2 amps, right?
right?
So if we got a 200 ohm resistor and 200 volts, the current is going to be,
Gonna be 1.
Okay.
2 divided by 200 is 1. Yeah, okay.
because remember the current's the ratio of the voltage to the resistance. So the current through a 24 ohm resistor when 120 volts is applied. So now we want voltage. We got a 10 ohm resistor and 0.5 amps of current.
Middle one,
Hmm?
the middle one's wrong, because you only got 1 amp. The red,
You're right.
so it should be 1 times 10, should be 10
Yeah.
volts.
You're right. What if we caught that before and I never fixed it?
1.5 amps.
Right.
Fix.
Oh, I'll fix it. This
Yeah.
is 1.5 amps.
Yeah, right.
Flowing
Yeah.
through it. That was probably the mistake there. Probably dropped off the 0.5.
Probably.
But formula, if you plug in the numbers, that's the way it works.
Right.
And then the last one for 50 ohms at 2 amps. 100 volts.
Mhm.
So a real question. What is the resistance of a circuit in which a current of 3 amps flows connected to 90 volts? You want R, you know E and I. I said. Resistance is the ratio of current or voltage to current.
Be 30, B.
Okay. What is the resistance of a circuit for which the applied voltage is 12 volts, the current is 1.5 amps? The arithmetic's getting harder. Got a decimal point in there.
Be 12 divided by 1.5 amps, right?
Yeah.
12 divided by 1. So that's gonna give you what, 13? They're not good at math.
Well,
Okay, 12.
it can't be
We're
bigger
gonna
than
divide-
12.
We're gonna divide 12 by 1.5 amps.
Right.
The closest.
Let's see.
Well, rounded up to 2 amps, what would it be? 12 divided by 2? It's gonna be 6, right?
So it'll be 8 ohms, right?
I think that's right.
I tell you, I'm slow, but I'll get there.
What is the resistance of a circuit that draws 4 amps from a 12-volt source?
Well, it'd be the same thing, 4 divided by 12. So you get 3 ohms.
You're on a roll.
That's because you went fast and I could remember.
What is the current in a circuit with an applied voltage of 120 volts, resistance of 80 ohms?
Divide 20 by 80. I don't have a calculator with me here. All right, let's see. 120 volts.
Well, it's the
divided
same
by
as
80.
12 by 8. That makes it easier.
Let's see. 1.5 amps.
Or 3 by 2.
Yeah, it said 1.5.
Oh. We got a new member. $1.5. Oh, one more. There's a lot of these. So the odds of getting one of these questions is very, very high.
All right, we measured 100 ohms resistance when connected across 200 volts. Be 2 amps.
He's really on a roll. One more.
We see.
All right.
All right,
Holy
we did
crap.
math and see it there.
There's a lot of
A
them.
lot of people in there.
I guarantee you're gonna get one of those questions. They're all in the same group.
Okay, so we had a little bit more complicated here.
Why?
Am I the only one that's answering these questions?
Apparently so.
Well, they're nodding.
They're in full agreement. They're just letting you go first.
We don't know about Christine.
Let's see. That would be 1.52.
Oops,
Maybe one
sorry.
vote.
There you go. Oh, I thought that was the end. 10 ohm resistor and 1 amp. This is a hard one. Need a calculator for this one.
I'd have to guess that one.
Well, you don't have to guess, you know that one. Voltage is what?
Just think of the formula. The pie chart.
Current times resistance, right?
Current times resistance.
Mm-hmm.
1 times 10.
Resistance here, so I've got a current of 1 amp. Well, that's not current though.
Yeah, got a current of 1 amp. And you got resistance of 10 ohms.
So you have 10 volts.
How about that? Oh, no, another one. So what if we got a 10 ohm resistor and 2 amps?
Well, you're looking at 20 volts.
I think he's got it. All right, so what happens if we put some of these resistors in series and parallel? So if we put them in series, the one thing we know is that the current through all of them is gonna be the same. The voltage across each one may be different, but the current will be the same. So if you look at the little diagram there, okay, the voltage across R1 is gonna be 5 ohms times that 1 amp current, or 5 volts. In the case of R2, this is a good example for showing the difference. It's also 5 ohms and it's got 1 amp through it, so it's another 5 volts. So 5 volts will add up to the 10 volts of the battery. Because the voltages around that loop have to equal 0. But the current through those is going to be the same.
So you look at 10 volts and then look at the total resistance, which is the sum of R1 and R2, which is 10 ohms. So you got 10 volts and 10 ohms, so you know, it tells you there, but you know that's why your current is 1 amp. And since you got 1 amp flowing through a 5 ohm resistor, that's 5 volts, so you got 5 volts on each resistor to add up to the total voltage.
But say I had changed this to 7 ohms and 3 ohms. It's still 10 ohms total because they're in series and it's 1 amp flowing through it. So it's still going to be 10 volts. But I would have 7 volts across this one and 3 volts across this one. So the voltages will depend on the current and the resistance. The current will only depend on the total resistance and the voltage.
That makes sense.
I'm working on
All right, well, we'll complicate it. We'll do a couple and then talk about parallel. In which type of circuit is DC current the same through all components?
series, A,
And they specifically said DC. Of course, with resistance, it doesn't matter, but if they were non-resistive, then that formula doesn't work. So if we put them in parallel, okay, I know that the voltage across them is going to be the same, but the current may be different.
well, that's gonna make your amperage different too, right?
Depend on the total amount of resistance,
Mhm.
yes. So it'd be voltage divided by the effective or the equivalent resistance. Now, when we put them in resistors in parallel, okay, the equivalent resistance is going to be less than the lowest value. So if we got a 5 ohm resistor and a 2.5 ohm resistor, we know that the equivalent resistance is going to be something less than 2.5. If this R3 was an infinite resistance, it would be 2.5. If it's anything less than that, the effective resistance is going to be lower. For instance, if they were both 2.5, it's going to wind up being 1.25. So the way you calculate those, in a nice simple one where you got 2, and this only works for 2. Oh, I didn't put it on there. You can multiply the 2 together and divide them by the sum and get the equivalent resistance. Otherwise, if you got more than 2, you've got to do the reciprocal of the reciprocals. So you take the reciprocal of the sum of the reciprocal of each value, which looks a lot nastier than it is. It's actually fairly simple. You just plug in 1 over R1, 1 over R2, 1 over R3. But the bottom line is the voltage is the same, whereas in series, the current is the same. So which type of circuit is the voltage the same across all components?
Will be A. Series. Well,
The voltage the same, not the current.
yeah, parallel then, voltage be the same.
Right. Okay, so we learned our little pie chart. That ohms are units of resistance, and in a series circuit, the same current flows through all the components. And in a parallel circuit, the voltage is the same across all components. Assuming it's a DC circuit.